All right, ladies and gentlemen, it's time for a lesson on radians and degrees. I know I've been alluding to this idea of radians being different than degrees, and it's time that you finally figured it out. So, what's going on is radians and degrees are different kinds of units for angles. It's much like how there's feet, and there's also meters, right? You can measure a length in meters, or you can measure in feet, you can measure in centimeters. Those are all just different kinds of units. And this is the same idea. So degrees, we're used to that, right? 360 degrees is all the way around. 90 degrees makes a corner, right angle there. 45 degrees is, halfway between horizontal and vertical. So you got different degrees there. Well, radians are the same idea, except it's different kinds of units. And these units use pi. And a quick conversion here that you can see, pi radians is the same as 180 degrees. So if you're thinking about, maybe you have a circle. All right, if you start over here on the right side and you rotate 180 degrees, you'll be over here, and that would be pi radians. If you continue to go all the way around, that would get you to 2 pi, but that's the same as 360 degrees. So that's the conversion. It's kind of a weird conversion, and why would someone want pi to be in there? But it's going to be really important for when we talk about the unit circle. Because these are actually going to match up with your arc length if your radius is 1. And we'll get to what that means much later. But yes, it is useful for different things. So that's why you're learning about it, so we can use it later for different things. And so, if you want to convert between these two kinds of angle measurements, here's your little formulas. This is what you times by. It's a little conversion. So if you want to convert 2 radians, as in you're like at 60 degrees, and you want it to be in radians, you're going to times by pi over 180. And that will tell you how many radians it is. It is going to be very common to have fractional answers. And so you'll want to, kind of get used to it, be able to use a calculator to help you deal with fractions and simplify fractions, things like that. This would give you 60 pi over 180. But luckily, 60 over 180 does simplify to be 1/3, so you'll get pi over 3. And this would be the exact answer. That's the exact number of radians 60 degrees is. But if instead I wanted like the decimal approximation, you could put that in the calculator. It's 1 point something or another. Give me a sec. Yeah, you just do pi divided by 3 and you'll get it. So pi divided by 3, you're looking at about 1.05-ish. But mainly I want you to put down the exact amount. So that's going to be all of them are going to have pi's in them somewhere when you're dealing with radians. If you want to go from radians to degrees, say I have 5 pi fourths radians, and I want that in degrees, you're going to multiply by this guy. So it's the previous one, but flipped. It's because you're going the other direction. So if you want to turn this into degrees, you're going to times by 180 over pi. And the convenient thing about that is the pi's are always going to cancel out, because the pi's is what radians are measured in. And so they cancel out. And that's going to leave you 5 times 180 on top, which is 900. And you got 4 on bottom. You can actually do that division. It comes out to be a nice number of 225 degrees. So that's pretty much what the lesson is for this. There's one other thing we're going to be discussing, but we'll focus on this first thing first. We're actually going to skip 1 through 12 for a moment and do some converting here, converting from degrees into radians. Let's start with kind of a nicer number here, 45 degrees. And I want you to, just kind of say to yourself, what would you multiply by to convert this to radians? If you said pi over 180, congratulations, that's correct. That is what you're going to be timesing by. So that'll give you negative 45 pi over 180. And this does simplify these here. It turns into 1/4. So you got negative pi over 4. If you don't believe me, you can put 45 divided by 180 in your calculator and then convert into a fraction and you get 1/4. And since it's negative, it's negative. So ta-da, we converted to radians. And I want you to stop there. I don't want you to get the decimal approximation. So I want to give you a chance to try out one on your own. Let's just do this one, number 13. Go ahead and pause the video and see if you can convert it to radians. Alright, so if you times by pi over 180, congratulations, you will get negative 640 pi over 180. Sorry, it's not looking very readable, but it does simplify a wee bit there. 640 divided by 180, converted to a fraction. You're actually looking at 32 pi ninths, and it did have a negative, so I'm going to put a negative there. And voila, we've converted. If you want to use a Desmos calculator to help you figure this out, let me pull up a Desmos one. I can do divided by 180. And if you look over here on the right side, next to your answer, there's that circle with a couple boxes in it. If you push that, it converts it to a fraction for you, which is awfully convenient. So yeah, pushing that button changes between decimal and fractions. So that's a handy tool when you're trying to convert these things. All right, well, let's go to one other example of converting from radians to degrees, and you're just going the other direction. So I got 23 pi 12ths radians, and we need to convert it to degrees. To do that, you're going to times by 180 over pi this time. The pi's are going to cancel, and you're going to get 23 times 180 on top, which is 4,140. And then 12's on the bottom. This definitely simplifies a little bit here. So let's go ahead and divide by 12, and you actually get 345 degrees. Just, it goes in evenly. Awfully convenient, that. So there you go. There's a conversion. I want you to try out one on your own. Here, let's do, let's just jump to 24. Go ahead and try out 24 on your own. Pause the video and give it a shot. Right, a few times by 180 over pi, that's correct. Those are going to cancel out. Let's see, 161 times 180 is a kind of a large number, 28,980. It's going to be over 36. I believe that one's going to go evenly. I just a hunch there. We're looking at 805 degrees. So there we go. We did it, 805 degrees. So now we've kind of done a few at the bottom there. I do want to talk about this first part because this is mainly a vocabulary thing about what this is asking. It's asking you to find a positive and negative coterminal angle for a given angle. And what coterminal means, it's the same spot. And so it's like if you start at 0 degrees and then you do a 360, you're at the same spot, you're facing the same direction. That's what that means. Or if you're at 45 degrees and you spin all the way around, you're at 45 plus 360 degrees, which is going to be 405. So it's just there at the same spot on the angle as you go around. So a quick way to convert the degrees to another coterminal angle is just to add 360 degrees. Oh, but you can also subtract 360 degrees and get another coterminal angle. And this wants you to get a positive and a negative one. And so I can do 165 plus 360 to get 525. And I can do 165 minus 360 to get negative 195. And these are coterminal angles with the original ta-da. If you look down later, there's some with radians. And use 360 degrees, which is all the way around, corresponds to 2 pi radians. And so if you want to get a coterminal angle for something like this, you're going to add 2 pi. You may have noticed these are fractional things, and so you'll have to deal with the fractions. But it's not bad. You do negative 11, 6 plus 2, and then you can convert that to a fraction, and that's going to give you pi 6. If you want to see that on the Desmos one, I'm going to come here and clear out all this stuff. I need to do negative 11, 6, and then go to the right and push plus 2. Enter. You'll see on the right it got a decimal. I push the little circle with the boxes in it and converts it to a fraction, and it's 1/6. So that's where 1/6. And so yeah, if you just leave out the pi's and tack it on at the end, you'll get your coterminal angle. Don't forget to subtract 2 pi as well. Here, we'll actually do it on the calculator here. So I actually just go up and change this to subtract 2, and I get negative 23/6 on the right side. So it's negative 23/6 pi. So there's my coterminal angles. And there you go. That's how you do your radians and degrees assignment.